Good afternoon. So our project was cross-site request forgery attack, demonstration and mitigation. My name is Martha Kenyanya and my team member is Oluwatomiwa Oladele. So, a cross-site request forgery is a type of malicious exploit where an attacker tricks a user into performing actions they did not intend to perform on a web application where they are authenticated. So this can lead to unauthorized actions such as changing account details, transferring funds, or other state changing requests. And basically, CSRF exploits the trust that a web application has in the user browser. And when a user is authenticated, their browser automatically includes this session cookies in request to the web application. And our report presents the findings of the methodologies used in the cross-site request forgery lab based on When Links Do Seeds lab. So some of the objectives for this report was to understand the mechanics of the CSRF attacks, to create a CRSF attack to exploit a vulnerable web application, and to implement and test mitigation techniques to defend against CSRF attacks. So the CSRF attack can impact both individuals and organizations. For individuals, it can make them perform unintended actions such as changing account settings, transferring funds, or other state-changing operations on the web application they're logged into. And for organization, we can find that it can compromise the integrity of web application and lead to unauthorized access and manipulate of sensitive data. And if the administrative account is compromised, it can result to a complete takeover of the web application and affecting all users and data within the system. So some of the potential consequences that we find after the CSRF attack is that it can cause data breaches, financial loss, reputational damage, and also legal and compliance issues. So some of the fundamental causes of the CRSF attack are the server cannot distinguish whether a request is cross-site or same-site. So same-site requests, they can be trusted because it's from the server's own page, and the cross-site request cannot be trusted because it's coming from other sites' page. And the browser knows from which page a request is generated from. So from this diagram, we can see that if a request is sent from the page of website A to the website, it's the same site, and it comes from website A to website B, it's a cross site. So yeah. So moving on, for example, if a web page can include a Facebook link, so when a user clicks on the link, HTTP request is sent to Facebook. So there are two types of CSRF attacks. We have the GET request and the POST request. And for our project, we use the GET request. And for example, if you consider an online banking web application, it allows users to transfer money from their accounts to other accounts. And if a user is logged into the web application and has a session cookie which uniquely identifies the authenticated user, HTTP requests to transfer $500 from their account to another account. And in order to perform the attack, the attacker needs to send out the forged requests from the victim's machine so that the browser will attach the victim's session cookies with the requests. So the attacker can place the piece of code in the form of a JavaScript code in the attacker's web page, and the HTML tags like image and iframe can trigger GET request to the URL specified in the SRC attribute response. For this request will be an image or web page, as you can see from the screenshots. So, and the next one, we also have the HTTP post services. And for you to be able to perform these post requests, it can be generated using HTML forms, and the above form has two text fields and a submit button. And when the user clicks on the submit button, the post request will be sent out to the URL specified in the action field with to and amount fields included in the body. Attacker's job is to click on the button without the help from the user. So we can see from this line of codes on the screenshots, we have named them from number 1 to 4. So on the first line of code, it creates a form dynamically. Request type is set to post. And then on the second line, where you have document.body, the fields in the form are hidden. Hence, after the form is constructed, it is added to the current web page. And then the p-submit, it submits the form automatically. And then the windows.onload function, so this JavaScript function, forge post, will be invoked automatically once the page is loaded. So some of the cross-site requests and these problems are, so when a request is sent to example.com page from a page coming from example.com, the browser attaches all the cookies belonging to the example.com. And when a request is sent to example.com from another site, the browser will attach the cookies too. Because of the above behavior of the browsers, the servers cannot distinguish between the same site and the cross site, and it is possible for third-party websites to forge requests that are exactly in the same as the same cross-site requests. So this is what we call the cross-site request forgery. And now next I'm going to pass on to my team member Tomiwa to continue from there.
So I'll be doing the demonstration of our project, which is cross-site request forgery attack. So for this project, we're going to be using the seed lab and the seed VM, which can be downloaded from the seed website. I've included the link in the report. For this attack, we're going to be doing a brief demonstration, and in this attack, we're going to be using the already pre-built egg application, which has been pre-built and set up in the seed VM. So we are going to be using the seed 20 version 20 VM. Now I've downloaded the setup files already. So this is the files. I've opened them. So I opened this particular place in terminal. So this is it in terminal. So to begin, we are going to do DC build. I've done DC build already. DC build. So this will build the container images that are needed for this demonstration. Then after that, you bring them up and you start them by using this syrup. So after starting, you can just go to a new tab to enter doc ps. This will show the processes running. So the first project, which is the MySQL is used to host the usernames and password. Some users have been created in the egg application. This is the egg application, is hosted on this IP. This is MySQL, is the one that hosts the usernames and password. So among the usernames and password, we'll be using two. One will be for the attacker, which is Sammy. The other will be for Alice, which is the victim. So the goal here is Sammy wants Alice to add him as a friend, but Alice refuses. So what Sammy intends to do now is to use Csrf attack to add himself to Alice's friend list automatically without Alice's permission. Now, Sammy has created an attacker website, which is this highlighted website there. So, in this website, Sammy embedded a link that will automatically launch itself once that website is visited. So what Sammy intends to do is to somehow get the link of that website to Alice, either by email or by a phishing technique. So once Alice visits that website, that GET request will be executed immediately, hence adding Sammy as Alice's friend. Without further ado, let's start. So after launching the Docker build and after building the container images and starting them, we move to the browser. So this is the web application, the egg application. Then the attackers page is here, this attackers page. Now we log in as Sammy. Now, why are we logging in as Sammy? We are going to start from the attacker's point of view. Now, I'm an attacker. I want to embed, I want Alice to add me as a friend without our permission. Now, what do? I go to members. I click on, anyone. Let's say I click on Alice. Now, I go to this add friend. Now, down here, you can see when I hover on this add friend, you can see the URL. So the URL looks something like that: www/add_friends, then the friend number. Now, for this lab, the how should I call it? The defensive measure has been intentionally turned off. Now, the reason why the defensive measure was turned off is to make the attack work. Now, when I'm able to get, how the friends looks like, how the add friend link looks like, which is this down here. Let me copy the link. Copy link location. Check for text editor. Yeah, text editor. So the link looks something like this without this. So the links looks something like this. Now, this is the 56 here is Alice's ID. Now, if you want Alice to click the link and automatically, make a GET request like this, the first thing to do as the attacker is go to your own page. Then for this lab, we are going to be using something called HTTP header live. That HTTP header live will be used to capture a GET request, because for this attack, we are going to be using a GET request method. Csrf, as we discussed earlier, can be done by GET or POST request. So for the GET request, which we will be demonstrating in this project, we will need the HTTP live header. Now, why are we using this HTTP live header? We need to get the profile ID for Sammy. So how do we get the profile ID for Sammy? We can go to Sammy's profile. We do edit profile. Now we can briefly edit the description. I am a very bad not ethical hacker. Now, just before we click save, to capture the post request, we open the HTTP header live and then we click save. This will capture the post request. Now, from this post request, we can go and this first entry, click this one, and then on this place, when we navigate to the last part, right here we can see the GUID for Sammy, which is 59. Remember, Alice's own was 56, so Sammy's own is 59. Now we go and embed this link right here. We embed this link right here, but this time we are going to change the ID to 59. Now we need this link to this HTTP request to be sent in from the attacker's image, but to do this we need to make sure that Alice is having a session in the egg application, because for this link to work, Alice has to be in session on the web application. So with this, we log out, close this, we log out, and then we log in as Alice. So we're going to assume now that Alice has been sent, the link, and then she clicks it. Now, before moving on, when Alice is in session, now what the attacker will do is the attacker will create a website that's, just a website like the add friend website here. That's this add friend website, the URL will be sent to Alice. So Alice will click this URL, and when she visits this website, that attack will be launched. That's this one here. So this one will be embedded in that website. Now the website has an image section. The website has an image section. This is it right here, add friend. So let's open it with a text editor. Yeah, so this is the body. Now we are using this image as the point of embedment. So what we'll do is, images in HTML, they have this automatic get response attribute. So since we know that, we are going to add this source, into the source, this link for the guest request that we want. You can see I've changed the ID here to Sammy's ID. So once Alice visits this website, this guest request will be automatically made, and then that will cause the Sammy to be added as Alice's friend. So we save and exit. Now going back to the web application. So we first go to Alice's friend list, and we see she has no friends. Now let's assume this link has been sent to Alice, like I said, and Alice visits that link while having a session on the egg application. Once she clicks the link, the HTTP GET attached to the image in this website will have been executed. Now if you refresh, you see Sammy has already been added to Alice's friend list. So how do we mitigate such attacks like this? There are two methods. We have same site token, and then we have secret token. In this demonstration, we are going to be using the secret token. Now, how do we use the secret token? In this demonstration, now let's go to the egg application, the egg application code. Now, how can we mitigate attacks like this? We use secret token. What does this secret token mean? It means you embed a secret token in every form in your web application, so that any form that is submitted from that web application must have that token. That token will be attached to every form, and if there is a form that does not have that token, or if there's a HTTP GET request or POST request that does not have that token attached to it, then it won't be allowed. Now let's open this crf.php. So what can we do in this case? Now in this case, this return was intentionally added to disable the countermeasure, but if we remove this return by commenting it out, and then we save and then exit. Now let's go back and unfriend Sammy, and then let's refresh. Now no friends. Now let's go back and click this link again. Let's refresh and then click the link. If you go back to Alice's and then click, you see it said form is missing token or timestamp field. So just like I said the other time, once the form is missing that token, then such Csrf request would not be allowed. So that is a way to to countermeasure cross-site request forgery attacks. Thank you very much.
So finally, for the conclusion, we find that this project provides a comprehensive understanding of cross-site requests, forgery attacks, and their implications of web application security. And through practical exercises, we explored the mechanics of CSRF, identified vulnerabilities within a web application, and implemented effective countermeasures using the anti-CSRF tokens. So this demonstration reinforced the critical needs for robust security practices in the web development. And by incorporating these measures, organizations can significantly reduce the risk of unauthorized actions and protect their applications from potential security breaches. And here are some of the references that we use. And thank you very much.